Today we're going to look at predicting products of chemical reactions. So we're going to be using the reaction type in order to predict products, and then we're going to balance those reactions. So if the reaction type's listed, we're going to use that. And if it is not listed, then we're going to figure out that first, and then we're going to determine what the products are with the correct subscripts by using their charges. And then we're going to balance it. So here are the steps that we're going to be using. Determine the reaction type first, predict the products, crisscross with correct charges, and don't forget about diatomic elements. So those are Hofbrinkel, right? So hydrogen, oxygen, and all those. And those ones only exist in nature in pairs. That's why we want to remember that. Write the entire reaction and then balance. So this first one's listed for us. So this is a combustion reaction. Well, combustion reactions will always form the same products. So it's kind of a easier one to predict. So I'm going to draw a little line right here though. So that way when I balance this, I have a spot to write the coefficient. So in a combustion reaction, we always have some fuel, so hydrocarbon with or without oxygen in the presence of oxygen to burn, creating or yielding carbon dioxide and water. So those ones are always the same for combustion reactions. So that's a pretty nice one. So now we're going to balance. So under the arrow, I'm going to write carbon, hydrogen, and oxygen because I want to count these and keep track of my counts. So on the left, I have 6 carbons, 12 hydrogens, and 2 oxygens. And then on the right, I have 1 carbon, 2 hydrogens, and then 2 plus 1 for our oxygen for a total of 3, okay? Okay, well, let's just get started. So I have 6 carbons on the left, which means that I need 6 carbons on the right. So I'm going to put a 6 as a coefficient right here. Well, that's going to change my number of carbons and my number of oxygens. So now I have 6 carbons, and then 6 times 2 is 12, plus 1 is 13 oxygens. Okay, next up, let's fix hydrogen. So I have 12 hydrogens on the left. So 6 hydrogens on the right on the coefficient line would give us a total of 12 hydrogens. And that's also going to affect our oxygens, right? So 6 times 2 is 12, plus another 6 oxygens is a total of 18. Okay, well, we can work with that because that's an even number. So it helps us out on this side in order to make those oxygens balanced. So on the line, I'm going to have to write a 9 as a coefficient because 9 times 2 is 18. So we're all done. And we don't write anything on this line right here. It's like there's an imaginary 1 there, but we don't write the coefficient of 1. So let's look at the next one. Synthesis. So synthesis means that we have 2 or more reactants combining to make one product. So I have magnesium and iodine, and that's going to combine to make one product. So off to the side right here, I need to figure out what that formula is going to be. And so I'm going to do that by writing out what the ions are for each of them so I can crisscross them correctly as a product. So magnesium, Mg. Magnesium's in group 2A, so we'll always form a 2 plus charge. And then iodine is in group 7A, so we'll always form a 1 minus charge because it just needs that 1 more electron. So if I crisscross these, I'm going to be able to get the correct formula. So over here on the right, I'm going to draw my little line so I have somewhere to balance if I need it. And then I'm going to crisscross Mg and I. So for every 1 magnesium, I need 2 iodines. So the 2 drops, the 1 drops, so MgI2. Okay, so to check if I need to add any coefficients, I'm going to write out my symbols and count. I have 1 magnesium as a reactant, 2 iodines as reactant, 1 magnesium as a product, and 2 iodines as a product, so we're already all balanced. So that was a synthesis reaction. Okay, now the next one looks a little trickier. So for this one, I have HCl, which is hydrochloric acid, and zinc, and what is that going to create? So the first thing is I got to figure out what the reaction type is. So I have a compound and an element. So anytime that I have a compound, with an element, it's going to be a single replacement reaction because one of those elements is going to, or one of those ions is going to be replaced. Now the hydrochloric acid, the hydrogen is a nonmetal, and so it's also an H+, so it's also can be a cation. So my zinc is going to replace the hydrogen, and so what I'm going to do is just draw a little line right here. So I know that that is going to replace the hydrogen over on the right. So let's figure out what this charge is going to be. So zinc is a transition metal, but zinc will only be a 2+ for a cation. And then my chlorine, Cl, is in group 7A, so it will be a 1-. So if I crisscross those, then it's going to give me the correct formula. So on the right, I'm going to draw a little line in case I need to balance. I'm going to crisscross zinc and chlorine. So for every 1 zinc I need, I have 2 chlorines because zinc is a 2+ and chlorine's a 1-. So ZnCl2 plus, don't forget about that hydrogen I got kicked out, or I should say replaced. But the hydrogen is a diatomic element, meaning that it will only exist in nature in pairs. So this is going to be H2. Now that's really important to remember because you're going to have to balance this. And if you don't have this written correctly, then it won't be a correct product and it won't be balanced correctly. So now let's balance. Hydrogen, chlorine, zinc. So on the left, I have 1 hydrogen and 1 chlorine and 1 zinc. And on the right, I have 1 zinc, 2 chlorines, and 2 hydrogens. So this one is a pretty quick fix because I already have 2 chlorines and 2 hydrogens. So on the left, if I write a 2 as a coefficient, that's going to change hydrogen and chlorine to both be 2. And now everything's balanced. Okay, let's look at the next one. So first, determine the reaction type. Okay, so I have CAF, which is a compound, and K2O, which is a compound. So when I have a compound and a compound, then that's going to be a double replacement reaction because we're going to have 2 atoms replacing each other, okay, or 2 ions replacing each other. So the potassium and the fluorine will make a compound, and the calcium and the oxygen will make a compound. So off to the side, just like I've been doing, I'm going to write the ions of all of these with their new combination. So calcium, Ca, will be a 2+ charge because it's in group 2A. And that's going to now combine with oxygen in my double replacement reaction. Oxygen will only be a 2- because it's in group 6A. Okay, these are ionic formulas. And then our other compound will now be potassium, K, which is a 1+ because it's in group 1A, and fluorine, which is a 1- because it's in group 7A. So it's going to make it a lot easier for us to crisscross these and write the correct formulas when we have the ions and charges written out. So my first one, I'm going to crisscross Ca2 and O2-. Well, that's a 1-to-1 ratio. So it's just CaO. Plus, I have another 1-to-1 ratio, Kf. Okay, so that way we can see that we have a compound and a compound, a compound and a compound, but they switched places. So now that we have our products, we can balance. So under the arrow, Ca, F, K, O. So I have 1 calcium on the left, 2 fluorines on the left, 2 potassiums, and 1 oxygen. And then on the right, I have 1 calcium, 1 oxygen, 1 potassium, and 1 fluorine. So just like the last one, this is a pretty quick fix with just 1 coefficient of 2 in front of the Kf, on the right, because that will give us 2 potassiums and 2 fluorines. And now we're all balanced. Okay. All right, for the last one, there's only 1 reactant. So anytime I just have 1 reactant, it's automatically going to be decomposition, because decomposition reactions are when you have one reactant turning into 2 or more products. Okay, so water. So when this breaks apart, okay, if this breaks apart, it's going to break apart into hydrogen and oxygen. But remember, okay, that hydrogen is a diatomic molecule, so H2, and oxygen is a diatomic molecule, O2. So it's very important to remember that so you have the correct products and you can balance it correctly. So now H and O under the arrow. I have 2 hydrogens on the left, 1 oxygen on the left, 2 hydrogens on the right, 2 oxygens on the right. Well, I got to fix my oxygens. So on this line, I'm going to write a 2 so I can fix my oxygens, but then that's also going to change the hydrogens. So now I have 4 hydrogens with 2 oxygens. Okay, so while trying to fix the oxygen, I messed up the hydrogen. So if I need 4 of them, I can write a 2. So it's a little small right there. A 2 in front of the H2 to give me 4 hydrogens. Okay, and now we're all balanced. So this is the process that you can use to predict the products. So first, and here in the practice, identify the reaction type. Okay, you can just write that off to the side. Predict the products and then balance. So remember, when you're predicting the products and you're writing them out, you need the charges in order to have the correct formula. Get to work.